Hello, so this is a solved problem video. So somebody asked me a question. The problem is given that A is 2 tangent A, 2 tangent theta, express sine 2 theta and cosine 2 theta in terms of A. So how are we going to find the expressions for sine 2 theta and cosine 2 theta? Okay, so let's digest the information. If you're given an information like this or a problem like this, you need to know the following ideas. These problems revolve, basically, these are identities. You need identities for sine to theta and cosine to theta. At the same time, you need to know how to manipulate this in relation to SOHCAHTOA. And since, or if you're answering this kind of problem, it means, at least my assumption is, you already learned what SOHCAHTOA is. So SOHCAHTOA sets the sine, cosine, and tangent functions in terms of their values. Like sine, or the SOH is sine of an angle is equal to the opposite side of the triangle over the hypotenuse. And this is also the same as y over r if we are using x, y, and r as values. The cosine of an angle will be determined by having the adjacent side divided by the hypotenuse side, and this is equivalent in terms of the x, y, and r values. This is our x over r. The tangent theta, or tangent, let's have it tangent, is determined by TOA. O means opposite side and A means adjacent side, and this is the same as y over x. So these ideas, adjacent, opposite, and hypotenuse, this came from a given triangle, that if you have a theta here, then this means this is the opposite side of the angle, and this is the adjacent side of the angle, and this is the hypotenuse, which is the obviously the opposite side of the right angle, or the longest side. Now if we place this in the Cartesian plane, and let's say we have a random point here, and this is x and y, from the point to the origin we can create a right triangle where the height of the triangle is y, and the this side of the triangle is the x, and this hypotenuse is named as r. Now if the theta is here, then that means our sine, which is the opposite over the hypotenuse, is y over r, and that's how we got the following expressions for sine, cosine, and tangent. Now another relationship that you need to know is that, well, this is something that we know in geometry, that if we have a right triangle, the relationship of the sides, the relationship will be x squared plus y squared is equal to r squared. So these are the things that you need to know in order for us to solve the given problem. So how do we proceed? So now those are the what we call prior knowledge in solving this problem. So let's start with the sine 2a, or sine 2 theta. I keep on saying a. It's sine 2 theta. So in letter A, sine 2 theta, so this is an identity, a double angle identity. The identity is 2 sine theta cosine theta. Again, this is something that you need to know before answering this problem. So since the goal is to express the sine 2 theta and also the cosine 2 theta later on in terms of A, it means we need to remove sine theta and we need to remove cosine theta and write these expressions in terms of A. And the only thing that we know is that A is equal to 2 tangent theta. So here's the trick. So if we are given that A is 2 tangent theta, what we will do is we will isolate tangent theta, and that is by dividing both sides by 2 it will tell us that tangent theta is a over 2. And as we know from our ideas here, the tangent is opposite over the adjacent. Our a over 2, so as you can see here, this is our a over 2. The value here, this is our y over x. Okay? So with this, if we will be creating a triangle, let's say just select the first quadrant, then our y, the vertical height, is a, and the adjacent side, which is x, basically is equal to 2. And let's still rename or name this as our r. Hence, with this triangle, and let's say this is our theta, 2 square plus a square is equal to r squared. Okay, so this came from x squared plus y squared equals r squared idea. And let's just keep it there for the meantime. We'll be using it later on when we look for the values of sine and cosine. Okay, so take note, we need expressions for these two trigonometric functions, sine theta. So from the information here, remember, sine theta is y over r. Y, this is our y, this is our x, so that means it is y, our a, divided by the r. But our r will come from 2 squared plus a squared equals r squared. So this is r equals the square root of 4, that is 2 squared plus a squared. Or in other words, this is a squared plus 4 equals r. So this is a over the square root of a squared plus 4. Now we have found the sine theta. Let's find the other function, cosine theta. Cosine theta is x over r. And again, in our triangle, our x is 2, our r, which what we already found, this is a squared plus 4. So once you have the sine theta and cosine theta in terms of a, all you have to do is to place these values in our 2 sine, so this is our sine 2 theta, 2 sine theta cosine theta, and we have found the values of this in terms of a. So this becomes 2, that's our sine, a over the square root of a squared plus 4. Our cosine is 2 a squared plus 4, and simplify this, 2 times a times 2, that's 4a. Square root of a squared plus 4 times itself, it will cancel the radical sign, so that gives us a squared plus 4. Okay, so this is the sine 2 theta. And we will apply the same idea for cosine 2 theta. Now take note, for cosine 2 theta, there are different or 3 versions for this identity. There is the 2 cosine squared theta minus 1, there is 1 minus 2 sine squared theta, and there's also cosine squared theta minus sine squared theta. Now you can select which one you are going to use. Okay, you can use the first, you can use the second, and you can use the third. Let's select the third one because we have cosine and sine. Take note, this means cosine theta squared minus sine theta squared. So again, simply place the cosine theta and sine theta in this expression. Cosine is, as we know from our manipulation, that's 2 over the square root of a squared plus 4, and you have to square that, minus our sine, which is a over the square root of a squared plus 4. Again, you have to square this, and then so when you square these values, you have 4, that's our 2 squared. Square the denominator, it eliminates the radical sign. You have a squared over again, a squared plus 4 fractions, subtraction of fractions, the same denominator will have a squared plus 4, then you have 4 minus a squared. Nothing to cancel, nothing to factor. So this is our final expression for cosine 2 theta. Okay, so let me summarize the idea. So what did we do in finding the expressions for sine 2 theta and cosine 2 theta? So very important are these ideas. Okay, if you don't know this, then you will not be able to, well, you could possibly find a different way, but this is what I can give you right now. You need to know these ideas, and then in addition, the identities for the sine 2 theta and cosine 2 theta. Okay, so the key is you set or you manipulate the given expression, isolate the function. Okay, this problem could vary, like in other problems it could be a 2 sine theta or 2 cosine theta, but the idea is you isolate the function and set it up in this way and relate what is tangent theta. If it's tangent theta, use y over x. If it's cosine theta, you use x over r. If it's sine theta, you use y over r. And then using the reference triangle, you have the x, y, and r. You have the a and 2 as your y and x respectively. Find the expression, and that's how you will get the expression for sine theta and cosine theta. Okay, so sine 2 theta by identities 2 sine theta cosine theta. What did we do? We replace the sine theta and cosine theta by the respective expressions in A. And if we simplify that, we will get the expression for sine 2A. Doing the same idea, but in this case you have 3 options. Take note, you can also use the second and the first and the second. Just make sure to manipulate it properly, and you will end up with the same expression, 4 minus a squared over a squared plus 4. So that's how you solve this problem. Thank you and goodbye.